Hello to everyone. My name is Patricia Nicolaus and with Professor Mile Jalalia from Faculty of Science, University of Split, I prepare a paper on the topic linear correlation between misconception and special relativity concept in high school, which I will present to you. In an increasingly complex and technology demanding world, it is important to prepare young people to acquire knowledge, skills, and competence that will help to solve complex problems, understand data and information, and be competent in collecting and evaluating evidence for responsible decision making. It is not possible to participate in the development and relevant use of modern technology without the relevant knowledge and skills in modern physics. In this presentation, we choose the basic concept of the special relativity because they are very interesting for research in the education of physics. The philosophical element of the special theory or relativity are very attractive and deeply challenging, but the mathematics is simply enough to be taught in high school. The complexity of mathematical forms in special relativity are comparable to the understanding and application of Pythagorean theorem, which is a part of curriculum even in a primary school. The relativity of motion is one of the central concepts in both classical and relativistic physics. Thus, by considering relativity, it is easier to monitor the cognitive development of students and the achievement of those concepts. Similar case we can accept with the concept of inertia frame reference frame, which is also central concept of both classical and relativistic physics. The motivation for the research of concepts in modern physics comes also from the fact that these subjects have been less analyzed comparing to other parts of physics. We have analyzed the difficulties in understanding the basic concept of the special relativity by high school students. We select and adapted questions about fundamental concept in relativistic physics developed and researched by J.S. Aslanis and C.M. Savage in 2013. We have analyzed the linear correlation between misconception of K concept in special relativity by high school students and discuss more comprehensive theoretical approach for finding principal correlation in a multidimensional system of correlated knowledge, skills, and competence. Some of learning outcomes in high school in physics are related to understanding of special relativity concept and their application to simple physics problem. Those learning outcomes integrate the following concepts are: first postulate of the special relativity. The laws of physics are the same in all inertia reference frame. Second postulate of special relativity. The speed of light in vacuum is the same in all reference frame. Time dilatation, length contraction, relativity of simultaneously, inertia reference frame, velocity addition, causality, mass-energy equivalence. Any task, question, or a problem in special relativity can be created by using one or a combination of more above listed concepts. We have conducted the assessment on two groups of students from the high school in Rijeka, Croatia, Gymnasium Andrija Mohorovića, which attend high school program in science and mathematics. The first group consists of second and third grade students, 46 of them, who have not taught the concept of the special relativity in their schooling and thus were selected to be the control group for this research. The second group consists of fourth grade students, 51 of them, who attend classes related to the special relativity and thus select the central group for this research. For the assessment of achievement learning outcomes, we select the adapted 24 closed-end questions from the inventory. Students had 30 minutes to answer the question. In addition to each answer, they were asked to rate on a scale between 1 to 5 how confident they were in their answers. For example, in the quest one question, then the scale should be 1, and if they are very sure to their answer, they should scale them to 5. Each concept from the special relativity which was assessed by the exam are linked to 1 or up to 4 questions. For example, 4 questions, 16, 18, 19, and 20, were related to the concept of first postulate of the special relativity, while only one question to the concept of mass-energy equivalence. This is question 24. From figure, it's evident that the central group of students in most of questions has better results comparing to the control group. The control group answered better only to 6 questions, but those questions were very poorly answered by both groups of students. Although the control group achieved better results for those answers, the certainty in their own response was very low. Thus we can conclude that their guesses the answer to those questions and by accident have better results, about 20% correct answer comparing to about 5% of the central group. If we analyze an example of one group of questions which is related to one of listed concepts, their correlation between students' answer could give us a better view to understand the particular concept and a rationale for possible misconception. As an illustration for analysis of correlation between answers to questions related to the same concept, here an example we use to concept time dilatation. That concept of time dilatation has been assessed by 4 questions 5, 6, 7, 8 with different view to the concept. The question 7 is related to quite unrealistic personal situation, travel through the galaxy at high speed, while other 3 questions are formatted in terms of general observation. As it seems from the figure, the question 7 has very low rate of correct answer compared to question 5, 6, and 8. This leads us to the conclusion that the students show more difficulty in accepting the concept of time dilatation. It is far from normal life and everyday experience. Answer to the question 5 and 6 can be directly compared because they compare the same event as seen from the 2 different inertial reference frames. Each observer measured that the other clock goes slower. The question 5 has been correctly answered by 80.39% by the central group, while from the control group there were 56.5% correct answer. The question 6 has a rate of 45.1% correct answer for the central group, while the students of the control group answered correctly only 41.3%. The linear correlation between answers for those 2 questions is relatively high compared to the correlation between other questions. Still, the obtained correlation are not high as it would be expected. From the analysis of correlation between answers of those 2 questions, we could conclude that these are difficult in understanding the asymmetry in which x measure that the y clock goes slower implies that the y measure that the x clock goes faster. Strong correlation we have found between questions related to the concept of inertial reference frame and first postulate. There are relatively high correlation between some questions that belongs to different concepts, which gives a relationship between different concepts, for example, first postulate, length contraction, and time dilatation. In statistics, the linear correlation between 2 sets of data we usually measure by covariance of 2 variables divided by the product of their standard deviation, called Pearson correlation coefficient. The Pearson correlation coefficient is normalized covariance which has a value between 1 and -1. The covariance can only reference a linear correlation of 2 variables, ignoring any other independent correlation. If the value of correlation coefficient is close to 1, the correlation between 2 sets of data is very strong. 0 value would be in case where there is no linear correlation between 2 variables at all. In case when there is a need to analyze correlation between a large number of sets of data, such as for correlation of answer to 24 questions, a more comprehensive theoretical approach should be used. It is very complex to analyze correlation between any two pairs of answers in this paper. In our case, there are 276 different pairs. The base for the key understanding to such complex system of correlation it is possible to find in the linear algebra, which is fully used and developed in various fields of science such as in quantum physics. The approach to find the principal correlation, including determination of eigenvectors and eigenvalues for the related system operator of correlation. This approach provides unique solution, which means that all original data of specific correlation of any pair of data can be reconstructed and uniquely represent as a linear representation of eigenvectors. The mathematical formalism for determination of principal eigenvector and eigenvalues can be found in various literature in physics and mathematics, for example, in any book of quantum physics. In this presentation, we have conducted a survey on two groups of high school students. First, control group of students who were not taught of the special relativity, and the second, central group of students who learned basic concepts in special relativity according to the regular curriculum in high school. The survey included 24 selected and adapted questions. The selected question converted the following concept in special relativity: the first and the second postulate of the special relativity, time dilatation, length contraction, relativity of simultaneous, inertial reference frame, velocity addition, causality, and mass-energy equivalence. As an example, we have discussed correlation between answers on questions that are relative to the same concept. For future action, we suggest to conduct a comprehensive analysis of the linear correlation by using diagonalization of the corresponding correlation matrix. The element of matrix described the form of multidimensional relationship between introduced concepts. Thank you for your attention. This is our contacts. Bye. Have a nice day.